In this video, we want to use Taylor series expansion to compute this value and this value. So this is the differential equation that we want to use, and this is the starting value. So we have to compute this and that. So now this is the formula for the Taylor series that we are going to employ. Yn plus 1 equals to Yn, and so on and so forth. Okay. So here, the starting value, which is the x naught, is 1. So this is our x naught, 1, and our y naught is 0. This is our y naught. So the h value is going to be x1 minus x naught. So what is our x naught? This is our x1. This is the next value of x from x naught. This is going to be 1.1 minus 1. So the step length is actually 0.1. So we have gotten the value of our h should be 0.1 because the x value is moving at 0.1 length. And stepping from 0.1 from 1 to 1.1, 1.2, and so on. So that's the step length, the h value. So now we need to, we say when n is equals to 1. So we want to get y1 here. So y1 is going to be y naught. So everywhere we see n, we change it to 0. So we have 1 factorial y naught 1 plus h squared 2 factorial. So this becomes y naught double prime plus h3 3 factorial y naught 1 2 3 as the top derivative, and so on. Okay, so this is what we need to do. So already we know the value of this. We need to get the value of this, this, and this, and also we also know the value of our h. So first, when we go back to our question, so the question is actually y prime is equal to x squared plus y. So that's it. Because this means y prime, divide the x means y prime. So we need to now begin to differentiate to get our second derivative, third derivative, fourth derivative, and so on. Okay. So the second derivative here is this. So we differentiate this one, we get 2x. Now if you differentiate y with respect to s, you're going to get 1, then you put the y s by its side, that is y prime. If you differentiate y, you get 1, then you put the y s by its side. Okay, so that's the second derivative. The third derivative is actually, you differentiate this, you get 2 plus, if you differentiate this again, you get the second derivative. Okay, if you go ahead to differentiate the fourth time, if you differentiate 0, then 2, you get 0. If you differentiate this, you get the third derivative, and so on and so forth. So you differentiate the fifth time, and so on. So now let's get the corresponding value for this. That is for y naught. Okay, so this is going to be the first y naught. Okay, this is going to be x naught squared plus y naught. Okay, so our x naught actually is 1. This is our x naught. Now the 1 square is 1 plus 0. So this is going to give us 1. Okay. Also for this one, the second derivative, this is going to give us 2x naught plus y naught 1. So 2x1 is like 2 times 1 because x naught is 1. That will be 2 times 1. That will be 2 plus this already, we have gotten this to be 1. This is what we got earlier, and that's going to be 1. This is going to be 3. And this third one is actually 2 plus the second derivative. Okay, that will be 2 plus. Now the second derivative we got earlier, of course, this is going to be naught. That's going to be 3 plus 5. And let's stop here. That's okay. The fourth one is going to be y, which was what we got earlier. Okay, and it's going to be 5. So nothing will change here. We're still going to be getting 5, 5, 5, and so on. So we can stop here. So we've gotten the first one. So the next thing we have to do now is we now begin to put all this value into this formula. So the formula here is we have this our y1, okay, which is actually the y1.1 that we want to get, okay. So our y0, this is what we're going to begin to substitute. Our y0 is actually 0 plus our h is 0.1 over 1 factorial. The 1 factorial is 1. So this, what we got here is 1 plus h squared, that is 0.1 squared divided by 2 factorial, okay, multiplied by this. This is what we got here, and this is the value. That's 3 plus 0.1 cube divided by 3 factorial, and that's the third derivative, and the third derivative is 5 plus, you can predict the next one, and so on and so forth. Okay, so then let's stop here, okay, just for clarity. Okay, so if we ask our calculator to give us the value of this, so we can just begin to put that in calculator and get the value of this. So I'm going to do that now because 2 plus times 3 is 3, okay, plus 0.1 cube times 5, 6. So what I have here is 0.115833. So now the first value we got here is this. So that means this is the first value that we want to get. Okay. Now, then we now need to get the second one. So the second value is when n is equals to 1. So when n is equals to 1, so we are going to have the second value. So that will give us y1 plus h of 1 factorial y1 y prime h2. You just simply change wherever you see n to 1, and h3 3 factorial, and so on and so forth. And not to forget that we already have the value of this. We just begin to change. So let's come back here. So we just begin to change this one from what we used to know it as before. So we already have this. So we now change this one to y1. This changes to y1. Okay, because this is what we are still going to be using, y1. Okay, so now the value will change. Okay, so our y1 is going to be 1.1 plus our y1 we got is the answer that we got here, which is 0.15833. Okay, and that's 0.15833. So if we add this together, so we're going to get 1.215833. So that's now our y1. So the second derivative, this also changes to, so this is going to be this and this and this. So the value here will also change. Okay, okay, so this is going to be 2 times 1.1, that will be 2.2 plus the last value we got, which is 1.215833. So if we put that, we're going to add from my calculator, it is giving me 3.415 8W3. Alright, so we also clean this one. This value will change, this will also change, and this will change. So this is going to be y prime. So that means we're going to add 2 to the last value we got. That will be 2 plus 3.1458W3. Okay, so this one will give us 5.14145.8W3. Okay, so I can clean this one. I don't need this one. Okay, so I don't need this value for now. Okay, so that is now the new value we are going to use. That is going to be this, and the last one. Okay, so then we go back to where we have this expression. So the second value, which is going to be y1. Y1 now is actually 1.2. Y1 is actually the last value that we got. That is this one is our y1. So that will give us 0.1158W3 plus our h is 0.1 over 1 factorial times. Now we now begin to put this value 1.2158W3 1.2158W3 plus 0.1 square 2 factorial. Now the other value here is 3.4158W3 3.4158W3 and lastly 0.13 factorial. That's going to give us 5.1458W3. Okay, so we can then punch in our calculator to give us this value. Okay, so 158W3 plus 0.1 times 0.2. Okay, plus 2 plus okay times 145. So what I have here is 0.2459. So we've gotten the value that we requested, that is y at 1.1 is actually 0.1158W3 and the other 1.2 is actually 0.2459. So that is how to use Taylor series to expand or to compute or solve differential equation numerical. I hope you find this video interesting. Thank you.